Hello viewers, welcome back to another episode of Dexter's Lab. Firstly, sorry if I sound a little bit out of breath, it's just because I've been bringing this thing up the stairs. So before we get started, I just want to thank the last influx of Patreon supporters after my last appeal. That's very much appreciated for your support. Hopefully that money can be set aside and I can look at spending on interesting things to tear down, and if we need anything that might be required to have a play with these Quantel products. So in this video I want to take a look at this. I've mentioned this many times in my videos and it's only been really briefly featured. This is the original DPB-7001 Paintbox. This is the unit that some of you probably remember I picked up from Retro Gamer VX a couple of years ago with the aim of actually restoring it to some kind of function. Now I have to admit I've not really been paying this machine much attention. It was in a bit of a state when I picked it up, unfortunately. Various things have been taken apart, played with, and I wasn't really sure of its status, so it kind of got a bit sidelined, put on the back burner. But I've decided that it's about time I actually took a proper look at this. So what I've done recently is a huge amount of research, and B, I've actually started reassembling this back into a solid piece of equipment, putting screws back in where they were missing, etc. We have also had a very quick look at the power supply which is in this, and we can't really find anything wrong with it. So I think after this video I'll actually have an attempt at powering this up and see if we can get some life out of it. Now, one of the biggest problems that I'm expecting to have with this is the hard disk that goes with it. Although we may be able to get a functional paint box as in this part, unfortunately there are actually some files that this system uses which are on the hard disk. Now, if you remember, that hard disk in question was a gigantic 14-inch Winchester drive with an SMD interface, and we've had a few goes at trying to read it, but it's not really been very productive at all. So essentially we're kind of writing that off. Now that might mean that those files that this thing looks for when it boots up might be missing. What we're actually going to do with that, if that actually happens, I'm not entirely sure at the moment, but I think it's well worth trying to get this part of it working. At least then, if there is a chance that we can discover somebody else who's got a working one, or we can find some old floppy disks with those original files on, we may be able to get it working. So in terms of this actual unit, this, as I said, this came from Retro Gamer VX. He picked it up from an ex-BBC engineer, and I believe it was decommissioned in around about 1993, 1994, some kind of time period like that. So as far as we know, although Retro Gamer VX tried to power this up and get it working, he wasn't able to, but really it's the last time it was fully functional would have been back in the early 1990s. The original paint box, the DPB-7000, that was released originally in 1982, 1981, depending on who you speak to, and this is pretty much the same thing, although this is a slightly newer version. It is completely the same as what the original paint box was in 1981. As far as I understand, Quantel would manufacture these, even though it had effectively been replaced by the V series. So a little bit of brief history on the DPB-7000. I said it was released in 1981 by Quantel. It represented quite a monumental engineering task and research as well. They'd actually been working on the original paint box back in the mid-1970s with a frame store system that they had, which kind of was used in some of their other products. And they started realising that they could actually use that frame store and actually paint with it. So they started sticking a tablet on so people could draw. And it was all very basic stuff until this was actually released as a final product. As far as I know, the artist Martin Holbrook had a large input into the user interface and how this system actually worked. Now, although there had been painting systems or computer painting systems around before the Paintbox, you know, there was things like Super Paint, things like that that were sort of hardware based. This was the first one that was commercial, and it was Quantel had a huge success with the Paintbox. It kind of revolutionised how TV graphics were produced in the 1980s, and it has a huge legacy, and that's one of the reasons why I want to try and get this working. One of the probably the most instrumental programs that sort of brought the Paintbox to sort of everybody's attention was a BBC program which was produced in 1986, shown on BBC Two, and it was called Painting with Light, and that featured I think 5 or 6 artists who were invited to come in and just play with the Paintbox and look at it from an artistic medium rather than just a TV graphics point of view. So people were invited in here to actually start painting and creating new art on it. So what we're going to do in this video is have a really good tour of the DPB, and then I will take out each of the cards. We'll go through them because I actually have the service manual here, and I might even compare some of them to the cards which are used in the later V series, because there are a remarkable number of similarities between the two systems. The V series was most certainly based on all the tech that was in this original box. Right, as you can see, it's a rather large box, as many things were back in the 1980s. It's aluminium and steel construction, so there's a steel frame, and then there's various aluminium panels attached to it. It weighs, getting on for about 45-50 kilos with the power supply in the back, and it's 7U high. So as you can see on the top here, we have a number of buttons. We've got a power switch with a nice recessed spring-loaded thing over it. We have a couple of indicator lights. This one is called remote. That is used when you have remote access to the unit. We have a couple of switches here, bypass and mono. Bypass simply just bypasses all the video that comes into this system and just outputs it straight to the outputs, completely bypassing the all the processing that's in this, and mono just turns it to black and white. We've got a couple of adjustment pots here called chroma gain and the black level, so little tweaky adjustment things there. Chances are they were probably just set and never touched again. I've just turned this round. We've got to look at the side. Tons of vents everywhere. There's 3 fans down in the base here, and there are 3 larger fans up in the top cabinet. I will show you those in a moment. So let's just turn this round to the back so you can see all the connections. Okay, on the back we have this area here, which is the power supply. That's held in with 4 screws, and it essentially plugs in. And we've got 2 big handles on the back here to take the power supply out. Down at the bottom here we have all the video inputs and outputs. So we've got RGB and sync, all the usual stuff that you'd get with RGB and YUV video. And over here we have black burst and the data display. I'm not sure what the data display is actually for. So we've got a number of 25-way D connectors here. Those connect out to things like the tablet and the keyboard. And we also have a remote control and a printer. So you'd have a serial printer. And next to those we have the mains input, which is just a standard IEC. We've got fuse, some earth binding posts, and another printer port. And then right on the far edge we have all the connections that go out to the SMD devices, which include the hard disk and the floppy drive. Interestingly, the floppy drive uses the SMD interface as well. There's a small adapter card which is included in with the disk drive, which converts the SMD interface into the standard Shugart floppy interface. And then on the back of the power supply we've got a number of test points for all the power supply voltages. So what I'm going to do now is just remove the power supply, because it does make it quite a bit lighter. The power supply is rather enormous. So that's just held in with these 4 screws on the back, and then the unit just wiggles out. So if we have a quick look in the back while we're here, there's a fair amount of empty space in here. Most of this is taken up by the power supply that I've taken out. So you can see two connectors on the back there which interface into the power supply. So the mains input is actually brought up onto these, and then the DC then goes back down into this system, and there's a wiring block just in the back there which you probably can't see, and then connects up onto a large back plane at the back which all the cards on the front plug into. So there is actually a mains transformer down here in this corner, and there's a number of fans dotted around the place. I believe there's a contactor somewhere, and that once that is energized, that then powers up the main power supply and the fans, etc. So as you can see, the power supply is rather large. The actual supply itself is an Advanced Power Systems High Flex. It's rated at 750 watts. And what Quantel have done is actually taken the actual power supply and then mounted it in this frame with the connectors on and all the wiring and everything to actually interface into the back of the paint box. So you can see all the wiring here off all the connections from the back of the power supply, which then go through this loom onto the connectors at the back. So this is actually configured with a large 5-volt supply. I can't remember how many amps it is. I think it's 90 amps, I think. That's this big main module here, and then there's a smaller 5-volt one next to it, and then another module next to that which provides two 12-volt outputs. So they have these wired to give you plus minus 12 volts, and you've got the main 5 volts for all the logic, and then a separate 5-volt line which is configured as a minus 5 volts. So let's open this up and have a look at some of the cards. So this maintenance hatch just opens up and just folds down to give people access to all of the cards which are in this system, which there are quite a lot. So what I'm going to do is pull out each of these cards. We'll have a very quick look at it, and I'll probably reference the service manual as well, which will give us a bit of a clue as to what they actually do, although I do have a pretty good idea now. I've been working on these systems for a while. So as you can probably see, there are essentially two sections on this. We have the top section with all the logic, the actual processing stuff in at the top, and then in the bottom section we have what seems to be pretty much all of the analog sections. So they probably put those in a separate spot just to shield it from all the digital noise that's coming from these digital cards here. So what I'm going to do, I'm going to start at this end, work my way that way, and then we'll take a look at the bottom ones last. As you can see, there's a legend printed on the bottom, the back of the front panel, which just tells you where all the different cards go. Not all of the slots get used. It was actually available in a couple of different configurations, so there are often cards missing out of this. So let's pull the first card out. They all have these metal tabs that you can pull out, which allows you to extract the card out. Quantel used these types of cards on most of their systems from the 1970s up until the mid-1980s, when they switched over to the V-series systems, and this sort of style went by the wayside. So we'll just pull one of these out. Now this is the Computer 1 card. So this, as you can see, there's mostly just a 7.4 series logic. There is a 68,000 running on there. The main processor, which controls the whole system. So there's a couple of peripheral devices on there. Now there are some modifications that have been done to this by Retro Gamer VX. He swapped out a number of the tantalum caps, these evil devices on the end, these things here. They have a tendency to go bang, so he's replaced these with some electrolytics. So this is Computer S2, which is the other part to the Computer 1 board. Obviously you can see here we have some RAM and some EEPROMs. Unlike the V-series systems, the DPB has all its software in EEPROM. So that meant it booted up very quickly. There was only a few things that it needed off the hard disk to be able to boot, which is why it's somewhat frustrating that we can't access that hard disk. But as I said, we're going to try and get this working eventually. I'm going to be powering this up in a future video, and hopefully we can get some life out of this. Now, as far as I'm aware, the Computer 1 and Computer 2 cards should be able to boot pretty much on their own, so hopefully I can get some life out of it and get to the diagnostics console and then make some progress from there. So yes, most of the software is in EEPROM. This is detailed version 4.11 and has a copyright date of 1993, so it's obviously went through a number of revisions over the years, and then I guess it was converted to the V-series systems. So the next card along is called Digital Interface. Now I believe this is a newer add-on to the DPB to provide a digital video interface. So this would have been a later addition. Provides a digital video interface for the system, because obviously going over analog introduces losses and all that sort of stuff, so being able to transfer images digitally means you can do lots and lots of editing without any loss. So the next card along is the disk sequencer card. Now this is a card that we've been taking a fair amount of look at, because this is essentially the interface into the SMD drive, and this actually uses an AMD 2910 bit slice processor, and has these ROMs, programmable devices here, which kind of hold a bit of code which the Paintbox then instructs to execute, which then does all the interface stuff with the hard disk. So it tells it to, step the heads one track ahead, read sector X, and all that sort of stuff. So the next card along is the disk buffer card. So this obviously works with the disk sequencer and provides some buffer RAM for the actual hard disk operations. And of course the floppy disk as well, because that is also accessed over the SMD interface. And the next one along is called filter. So if I just refer to the service manual here, it says this card is situated in the data path between the disk and the painting stores. The card performs horizontal and vertical and rotation filtering to correct the effects and size changes on a picture. So obviously, I think what they're basically saying there, this does all the bilinear filtering and all the smoothing effects, so you don't get jagged, horrible lines and that kind of thing. And the next one along is called size control. So another nice looking board. From the description in the service manual, it says this card converts the system computer commands, which is the stuff that comes from Computer 1 and Computer 2, the main CPU, converts the system computer commands into store, address, control and data and filter parameters. These provide the required size and axis referenced picture data for the painting stores. But yeah, what we can see on there is a number of AM2901 CPC ICs. I believe those are probably some kind of bit slice processor. So it's kind of a little processory kind of card at a very low level. Next one along, we have a brush address. So yeah, that's pretty much just 7.4 series logic on that one, plus some programmable stuff. The service manual says the brush address card has the following functions. Latches a status word that determines the overall function of the machine. provides refresh, read and write access to the brush store, provides counters that define an array size for accesses to the frame store, and finally controls the drawing process. So this sounds quite an important card, this. It's sort of like a controls the sort of main functions of what the rest of the cards are going to be doing. So yeah, quite important on that, even though it's mostly full of 7/4 series logic. And the next card along is a card with not too much on it. Looks like mostly RAM and some 7/4 series. The description says the brush store contains contains 3 sections of dynamic RAM storage for the brush, the data interface between the system bus and the brush data bus, and the registers used to provide fixed colours along the brush data bus to the rest of the system. So this contains the actual bitmap of the brush, which is going to be painted into the stores. So obviously if this was just one flat colour, the bitmap was just all one colour, then you'd be essentially painting a square. If you had a bitmap like a circle, you'd be painting it like with a brush. But of course you can have, there'll be luma values in that, so you can have various things at different brightnesses which affect how the brush actually looks when you're actually painting. Hopefully you can understand that. I kind of know how this works in my head, but it's sometimes hard to explain. And the next card is the brush processor card. 2 brush processors are used in the system, one for luminance and one for chrominance. They are identical and may be freely interchanged. This card takes the data from several sources: frame store, brush store, frame store extension, brush store extension and pressure, and combines them in various possible mathematical ways to produce an answer for feeding back to the frame store. So I think what this is doing the maths on how to actually combine all the different things together to actually affect what you're actually doing in the actual picture store. So the pressure data from the tablet would come in, and this would affect how much adds to the original frame store and that kind of thing. So the next card along is exactly the same, and as it said, they are completely interchangeable, so they're identical. So the next one we need to look at is input timing card. So this card, the introduction says, this card is used only for live video input and is enabled when video input is selected by the artist. The computer sets function 0 in the status word of the brush address card and causes cell video to be asserted. This allows signals from the card to drive the address control bus and enables video data into the brush bus. When video input is selected, this kind of takes control and starts feeding data into the actual system. And the next card along is called Store Address, and interestingly this actually has a 7001 marking on it, which means that this is the slightly enhanced, revised version of the DPB. The original model number was DPB-7000, but that was superseded by the 7001, which basically had some, as far as I can tell, some bug fixes and various minor enhancements. And it is mostly 7/4 series logic with some programmable stuff as well. The service manual says this card controls the reading of the frame store at video rate and access to the store by the computer, which by computer it means the computer 1 and computer 2 cards. With reference to the circuit diagram, the circuitry on the upper right consists of horizontal counters and vertical counters providing video read address. The horizontal chain is clocked at pixel rate and provides a reset, blah, 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 blah. So yeah, this is basically creating all the timing to read the data out of the frame stores and actually produce a video signal. Okay, the next card we have is called Store, and in the service manual it's called Frame Store. So I think we can pretty much guess what is going to be on this card. So yes, we have a lot of DRAM. The service manual says this system contains 6 identical frame store cards. Each card provides storage for 8 bits of picture information. the system further splits the frame store into 2 groups of 3 cards with a separate store address controlling each group. So just looking up these actual DRAMs, they are 64 kilobit each. There's 4 rows of 20, and there are actually 3 store cards for store 1, and looking there's also 3 stores for store 2. So having a look up at the actual model numbers of these DRAMs, they are MB8264As. There are 4 rows of 20 on this card, which gives this card about 655k of RAM, which means once you multiply the 3 stores for store 1 and the 3 stores for store 2, that gives you about 4 megabytes of memory, which is quite a considerable amount considering this came out in 1981, was part of the reason why the system cost £120,000. So given that we've got another 2 store cards, we've got another store address card, and then 3 more store cards, we can skip all those because they're all just identical, which makes the next one combiner. So this is the combiner card. The service manual says this card takes the signals from the 6 frame stores, which is the 3 banks of memory, and combines them together in a programmable manner to produce a single full colour output. So obviously what this is doing is pulling all the data from those store cards and combining them together. I'm not quite sure how the actual video format is stored in those RAMs, but it's going to be based on luminance and chrominance. So it's going to need to sort of go through each of those cards and pull the right values for the right pixel, combine them all together to actually give you a actual colour value. And the next card along is output timing. That's the output timing card. Service manual says the output timing card serves 3 functions: to generate all the timing signals for the system, and make sure that they are gen-locked to the incoming locking signal, to store the cursor parameters and generate the timing signals required to place the cursor colours onto the video output, and to provide 32 switches readable by the system computer to act as configuration switches for the software. So yeah, it's mostly 7/4 series logic with some programmable devices. These are obviously all the switches that they just mentioned there, so provide some configuration information to the computer cards. Now I believe it's actually one of these dip switches here I need to flick to actually begin work on this and actually put it into a diagnostics mode and stop it trying to find the SMD hard disk. So chances are I'll be having a look at this card when I power this up. And the next card along is output locking card. And this one again has a 7001 label on it, so this is obviously a slightly revised board over the original Paintbox. So yeah, rather interesting board actually. We've got, it looks a whole lot more analog than the other ones. It seems complete with hairs for some reason. Interesting that it's got a little prototype area on there. But that might not be quite so much as a prototype. It might be a case of customers might have needed a slightly customised options, and that might provide Quantel the ability to easily provide modifications and stuff and customise things to customers' needs as they dictate. So they might not be really as in a bodgy fixing problems scenario. It's probably more customising for customers' needs. The service manual says the output locking card serves 2 purposes: to drive syncs and burst from an external video reference, to take digital data from the tape interface and convert to a video output for recording on VTR. It's interesting. I believe the tape interface is not something I've really come across before, but I have seen it mentioned in the Quantel Harry service manual as well. I believe they had some kind of digital tape recording thing which allowed you to record pictures in non-real time onto tape digitally, and then bring them back. It was like a long-term storage solution, so maybe this has that feature as well. Interestingly, on the back of this we also have a grey plate, which is actually a very thin PCB with effectively it's just one big ground plane basically, and that's painted grey, and it connects into the ground planes and obviously provides a bit of shielding. And the next card along is output processor card and has PAL written on it, so I think we can guess that this one is going to take the digital video and convert this into a PAL analog video. And yeah, it's all very analog. So yeah, really nice looking board though. We've got a number of hard coax cables running over to the back, which presumably then run out to the back panel. We've got another shielding plate on the back, and yeah, it's definitely looking very old school, that one. Let's see what the description says. Introduction: this takes the YUV picture data and converts it into 2 sets of coded and RGB analog video. So yeah, it converts the digital data into analog video. So you'd have a 2 types of output. One is the RGB and YUV outputs, and then the second one would be actually a composite PAL output signal as well. Right, so if we delve down into the bottom, I'm actually doing these in the order that are appearing in the service manual. So this one is titled Input Locking. Capture the input sync signal and synchronize the rest of the box to it. The introduction says, the input locking card performs 3 functions shown in the block diagram, namely sync separation, video clamping and data reconstructions for the tape interface. The 3 inputs to the card, RGB syncs, composite video and data, are routed to the appropriate parts of the card by the FET switch AG under computer control, blah 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 blah. So yes, the sync separator, that's going to extract the sync out of a composite video signal. So this one here is called Decoder Bypass, and doesn't look anything more than just a pass through from the decoder, which is here. So that looks a rather large card. Definitely an interesting card, this one. I can't really find anything in the service manual about a card called Decoder. And it could be that there's lots of stuff in the service manual which I haven't seen, so it could well be that they're calling it something else and I'm just not spotting it. So, but it's called Decoder. There's a lot on this. It's a two board thing with. I'll just put this down. You can see here that it just hinges up to give you access to the main section. So it'd be interesting to find out exactly what this is doing. There's we've got a microsonics device there, a delay line. Those BAL devices are probably delay lines as well. So it's definitely an analog video thing going on there, but what it's actually doing, I'm not entirely sure. Given it says decoder, it could well be that this is the input video processing card. Convert the incoming video. The ADC card accepts either YUV video signals from the chroma separator card or RGB video signals from an external source and converts the selected video inputs into 2 streams of 8-bit digital data. So yeah, this converts all the incoming analog video into digital. So before I go through and reseat all these cards back in, I'll just show you quickly the service manual that I've got. So this is an original Quantel service manual for the DPB. This came with the system from a Retro Gamer VX, and it's basically stuffed full of circuit diagrams, schematics, circuit descriptions, component lists and all that sort of stuff. So really, really useful stuff. So as you can see here, the brush store card, you've got a description, an overall look at how the system works. We've got component lists, a block diagram, and then we have a card layout, and then we have a schematic as well. Now, one thing I would say that one thing that has been mentioned to us is that Quantel like to leave things out of the service manuals. They would often omit certain devices on the schematics, just to make it really awkward, especially for people trying to reverse engineer the system and potentially, I guess, make copies of it. So unfortunately, there are some things in here that we've already noticed where we can see devices on circuit boards which don't have any mention at all in the service manual. So they are obviously being a little bit crafty there. But the good news about this system is pretty much all of it is based on off-the-shelf 7.4 series logic. There are a few programmable devices in it, which of course we don't really have access to how they're programmed now, but hopefully when I power this up and the power supply hopefully doesn't go bang, we can actually start working on this and actually trying to learn a little bit more about exactly how it works and see what we can do about getting around that hard disk issue. Okay, what I'm going to do is get this reassembled. I'm going to put the power supply back in, probably remove most of the, or all of the cards actually, and just power the chassis up, and keep an eye on the power supply for a bit, check, make sure it's all going to be okay. I will probably then plug in the Computer 1 and Computer 2 cards and see what life I get out of those. Now, if the power supply doesn't want to play ball, then obviously that's going to delay things a bit. So if you don't see a video for a few days, then that's probably what's happened. But hopefully, very soon, I will be able to post an update video, and I will detail what I managed to find when this system powers up and I can actually power these main computer cards up, and then we can start looking at the rest of it. Okay, thanks for watching everybody, and hopefully I'll see you soon.